Assalamualaikum everyone, welcome back with another demonstration of the premium paper numericals of physics. So here we are question number 2 part 5, which is actually the Newton's ring question. Let's move forward with the question. What is asked with it? Let's read it. If the diameter of the 10th bright ring, this is the bright ring case, is 0.005 meter, when wavelength is 5893 angstrom, that means 5893 into the 10 raised to the power negative 10 meter, if you want to convert it into meter, is used in Newton's ring. What radius of curvature and the thickness of the film? You have to find out that. Okay, right, let's write down the data. The bright ring is 10, that means we're going to denote n as 10. Now remember that if this was not the case of Newton ring, then we would denote any number of ring with m. But if this is the case of Newton's ring, so the number 10th bright ring will be denoted by the capital N. And we have got the diameter as 0.005, so d is equals to 0.005 meter. And moving forward, we know that now we're not given the radius, so we know that diameter is twice of radius. So in other words, if we want to find radius, we can do that 0.005 divided by 2 is equals to, this is equals to 2.5 10 raised to the power negative 3 meter. Now moving on forward, what we have the wavelength, so we're going to write it down. Wavelength is equal to 5893 angstrom, which in other words, you know that angstrom stands for, stands for 10 negative 10. So in other words, if you want to convert it into meter, 5893 into 10 raised to the power negative 10 meter. What else information we have? We don't have any other information. Now we're gonna simply say that we have to find the radius of curvature, which is given as capital R is equals to question mark, and we have the thickness, which is given as, now we have two formulas. For the radius of curvature, we have the formula as R n is equals to n minus half lambda r. Now why do I use n minus half lambda? I could have used only n lambda r, because of the reason that it is the bright ring case. I use the n minus half lambda r case, and we're just going to simply substitute the values. We know that r square n, but for substituting the values, we can also do this, that we are going to make this r on the left hand side and all the rest of the values on the right hand side, but that is not convenient process. So what I usually do is that I will write the values first. Now this is 0.0025, so you should denote this r with the small n, as this r is the capital N, r. Now the value of n is 10 over 1/2, and lambda is 5, 8, 10. I know it's getting messy, I'm sorry for that. I don't have much space on this board. And r, this is what we have to find. In short, what you will get the end result when you're going to take LCM of this, when you take LCM 1 divided by 2, 10 divided by 20 minus 1 is 0.2, and you get that 9.5. So in short, what you will get is 5 point, when you solve this whole value, you will get that 5.59835 to 10 raised to the power negative 6 into r. You're going to take squares on both sides. You're going to take squares on this side, and you're going to take square on this side. This will cancel the root, and this will you will multiply it 0.0025 into the power of 2. And in short, when you, this is all mathematics here, when you will do that, the value which you will get is 1.1164 meter. What you will do is that first of all, you will take the square of this value, and then you will bring this value, divide this value with this value. Then when you will divide let me tell you, 6.25 10 raised to the power negative 6 is the square. So we'll divide 6.25 10 raised to the power negative 6 with 5.59835 into 10 raised to the power negative 6. 10 raised to the power negative 6 and 10 raised to the power negative 6 will be cancelled. You will only be left with just 6.25 into 5.59835, which will give you this value of 1.1164 meter. And let's move on to the next part where we have to find the thickness T. Let's move to the next part where we have to find the thickness T. Now to find the thickness T, so I haven't got any space, so I erased the solution. I hope you would have copied it down. If you had any confusion, you would have seen it. So to find the thickness T, we know that in the very start we have this formula r square is equals to 2TNR. This T is actually the thickness of the lens. So T is equals to r square divided by 2r, and here we will only substitute the values. Now we know that r square is provided as 2.5 10 raised to the power negative 3. So 2.5 10 raised to the power negative 3 to the square power, and our capital R, which we just found in our last answer, was 1.1164. And if you solve it, multiply, if you multiply, take the square and then multiply this and divide both of these values, the answer which you will get is 2.799 10 raised to the power negative 6 meter. And this is the thickness. That's it. That's the solution which was required in this video. Thank you.